Welcome everyone. My name is Jad El-Khoury and welcome to this whole day workshop on the OSLC standard and its underlying approach or technology, linked data. This is a whole day project, so in the morning I will be talking a little bit more about what is the standard and how does it look like, etc. And then in the afternoon the hope is that you will sit on your computers and have work on the standard and do some implementations, look at some code. The morning session is pretty much based on material from Steve Spiker, which is one of the active members of the OSLC standard, but I've modified it a little bit to sort of suit the audience here, but also my taste of how I do presentations. Okay, so but please refer to this presentation also if you want. I hope that by the end of the day, you do have a good understanding. My aim is that you will have a good understanding of how the OSLC standard is structured and what is its content. How do they think? What are the thoughts behind the standard? How does it look like? We will look in details, relatively speaking, into the core specification, the main part of the standard, but also sort of the domain specifications, which is what builds on top of the core. But to do that, I think we need to start by discussing this linked data approach, which OSLC builds upon. And if you have my understanding is that if you have a good understanding of linked data, this becomes quite relatively trivial, for the lack of finding of a better word. We will look at technologies and standards like RDF, RDF schema, etc. Once you know these, OSLC becomes easier to absorb also. And then in the afternoon, we will have hands-on experience on developing an OSLC adapter. So we will put this into practice and see how that looks like. I hope you have, for me to do this, my assumption is that you have some basic understanding of web technologies, web services, HTTP, URI, at a very basic level. For the afternoon, it will be based on Java development in Eclipse. So hopefully you also have some experience or at least confident that you can manage with that. And things like web development also. If you don't, I think you will still manage. We're a small group, so we will have a discussion a lot in the afternoon. So it's okay. If you do other kind of programming, I think you'll manage very fine. It's not like you're going to have to do a lot of programming yourself. But if you're familiar, it's better. Okay? Okay, a little bit about myself and who we are here. As I said, my name is Jad El-Khoury. I work at the University of Royal Institute of Technology, KTH, Department of Mechatronics. I'm a researcher. I spend about 50% of my time working on research, and 50% is education. So I have responsible for courses, I give lectures. I'm responsible for a master's program in engineering design. My 50% research is pretty much focused on tool interoperability. A lot of work at the moment is about OSLC. You will not hear a lot about my research work today. I promise I won't talk about that. I think I will only talk about what is OSLC. So I won't sort of spam you with that. In the last 50 minutes, we will mention something which I think is practically useful for you when you're developing OSLC adapters on something, a practical tool we're developing that I think could be useful for you. If we want to discuss it more, of course, there will be space to do that. But today's lecture is not research. It's really about the basics of OSLC. Previously, I've worked a lot about model-based development, but for me, that's really connected to tool interoperability. If you own and know how the data, if you manage well the information behind your product development, that's sort of what model-based development is about for me. Models or information for me is the same thing. I've been committing to this OSLC Leo project, which is where the implementation of OSLC is in Eclipse, and recently I've become a committer also. So I'm sort of active in that community as well. Yeah, that's a bit about me, and Fredrik also has been helping with this.
So yeah, briefly, my name is Fredrik Warren, and I work actually at KTH as well with Jad, but I share my time between KTH in Sweden and a research organization in Germany called Office, nearby Bremen. And I'm a researcher as well, so in IT, but I'm really focused on tool interoperability. And in the last years, I've been working quite extensively in many European projects focused on lifecycle interoperability, into which OSLC standard have been adopted and extended. So I'm really also active in this community at European level.
Thank you, Fredrik. Okay, why we want to talk about linked data before I talk about OSLC? OSLC, pretty much, in my view at least, I don't know if this is official, that really builds a lot on the linked data technology and the whole linked data approach. So we need, which is a whole set of technologies that OSLC builds on. This is not exactly a true picture. OSLC, for example, this is more of an architectural style, it's not a standard. Linked data is more of an approach that sort of encompasses all these set of standards. OSLC doesn't really talk about this part, for example, or RIF, for example. But this is pretty much sort of the big picture of what the stack of technologies you need to understand if you want to understand OSLC. So I will start here somewhere, and then we sort of move on to the OSLC part. Okay, and this is how the agenda looks like for today. I will mention very quickly about sort of the OSLC approach, the reason they're doing the approach they're taking on tool interoperability, and then I'll go into details about linked data and the RDF standards, and then I'll go into more details on the OSLC standard itself. We will look at both the core specifications and then take an example from one of the domain specifications. We will take requirements management as an example. And this is the morning session, and in the afternoon we do the tutorial. Okay, the OSLC standard. What is the problem OSLC trying to solve? Maybe you just heard the term now, but what is it OSLC is trying to do that people haven't managed to do before? OSLC is about tool interoperability, or how do you sort of interconnect data in your development environment. Previous approaches have either gone for this point-to-point integration. If you have two tools in your development environment and you want to integrate them, sort of the spontaneous, one of the solutions is to do an interface between the 2 points, so you can get the two tools to interoperate. Of course, the problem with that, if you can expand that, once you have more and more tools, you will have a scalability problem, which is not sort of maintainable. What happens if you want to do changes on one of these sources? Then you have a sort of an impact on many other sources. So that's sort of one extreme approach people have taken earlier. A reaction to that, I would say, would be to sort of say, okay, let's not integrate all these sort of distributed tools. Let's put everything into the one platform, which is sort of spontaneously a good thing to do. You just sort of put everything in the one place, and you have no integration problems anymore. Looks fine, except that now you're locked into this one platform. It's probably not the optimal solution for all the tools. So if you want to do any changes, if you want to introduce another tool into this platform that is not already predefined, then you're back into where you started here. You have an integration problem. I see these as sort of the two, let's say, extremes. I mean, no environment is either here or there. In an organization, you have a lot of platforms. You have PLM systems or ALM systems in place. Nevertheless, you have sort of other preferred tools you want to integrate with these platforms. So you end up having to do that kind of point-to-point integration with sort of centralized platforms. Yeah, so these are the two sort of past experiences or approaches to tool interoperability. Of course, both lead to these costs, both in terms of management of change over time, sort of evolution of your development environment. How do you manage that? But also sort of this lock-in effect that you're sort of stuck with an environment where it becomes harder and harder to sort of change a tool. If a tool is sort of getting out of, is being demoted, or you want to deploy another tool, a newer version, then you have a cost in that. And OSLC tries to deal with that approach by sort of maybe, in my view, maybe finding a way in between, where I can see it as maybe like a point-to-point integration, but at least you sort of try to have a standard on how the interface between these tools is done by adopting the architecture of the internet. I mean, the internet is quite scalable, and that's a good. We know that scales. You have many servers out there, and then they all integrate quite well. So if we borrow this concept of the architecture, if we borrow this architecture of the internet, where you have many web servers and they manage quite well to integrate, maybe we have a good starting point. If we take this linked data approach, which is sort of putting semantics behind these web servers, this is sort of another approach OSLC takes. And then they try to sort of standardize the interface, and that's where the OSLC domain specifications come into place. So you have federated sources. If I go back to this picture, if you sort of have standards that tell you how these sort of sources should interact, then it becomes relatively cheap to maybe replace one tool with another, as long as you keep the interface standard. So then that's sort of what they aim to do, to standardize these interfaces. I know sort of point-to-point is a sort of an ugly word in this world. You should avoid point-to-point. But for me, as I see it, it's probably not a problem if it's point-to-point, as long as the interface is standardized, which makes it easier to replace. And then their approach to do these standard interfaces is just to focus on take a minimalistic approach. Another sort of, if you look at previous standards, like the STEP standards, where the interfaces have been, they try to define a very complete standard on how tools should interact. That also quite a heavy kind of standard to implement. It's really hard to interpret. Here they really focus on a minimalistic integration. What is the minimum effort needed to integrate tools? And you focus on that. We look at an example of that also. Okay, how did OSC start? It started as an open community where you focused on to build sort of specifications on how to integrate software. The approach is sort of you identify some integration needs between particular domains. Let's say, how do I integrate a requirements management tool with a change management tool? You define a minimal set of scenarios to do that, and then you sort of course, work on a draft, define the interface on how we can get these two tools to integrate for that particular scenario or for that particular small set of scenarios. And then you sort of define the specification. And then you go back and sort of add more scenarios and then try to cover and make the specification more and more. And that really keeps the specifications very small, manageable, and sort of focusing on the needs. It's like an agile way of developing specifications. Compared to my other favorite, which I tried to work on before, with the STEP standard from the mechanical engineering domain. I don't know if people are aware of this standard. It's huge documentations on exactly every detail in the sort of how the data should be defined and everything should be there. And that's quite heavy to manage. OSLC takes a more minimalistic, agile approach to defining the specifications. And it keeps growing all the time. It started as an open standard, so it's an open community where people could join, very low threshold to be part of this community. And now they're moving into OASIS, which is a standardization body, which is still open, but at least you have some standardization body behind them. And both, it's not a migration, so a lot of activities are still happening at open services, and that's where you work on the scenarios and people can contribute. And then you get more formal specifications in OASIS. Okay? Please ask questions if you're wondering anything. Okay. This is the big picture of how OSLC relates to sort of the other activities. So as I said, it started as open services, but now it's part of the OSLC, the OASIS standardization body. OSLC borrows a lot from the W3C standards, things like the linked data platform. Things like RDF, for example, is something OSLC builds on, so they're not starting from scratch. But also, part of the results from the OSLC committee is being sort of proposed as standards in the W3C. For example, this linked data platform working group, which are results from this community that are being standardized. So there's a good, interesting interaction here happening. And then this is the specifications, and there's Eclipse Leo, which is the one we will be using this afternoon. That's an SDK or a set of software packages to help you in your implementation of adapters. The most mature part is, unfortunately for you, Java. But there is a .NET alternative to Leo also, which we can discuss also. And Python, I heard also there is something somewhere on that. We will be working with OSLC Leo this afternoon. Okay, so this is just a general idea of OSLC. Let's go back and discuss. Let's ignore OSLC for now and just talk about the linked data approach and then its standards. What is linked data? Anyone have heard of linked data or already aware of this? So I know how to skip it or not. It's all fresh for everyone? Yeah? Okay, yeah. Basically, linked data is an approach. It's an approach, actually. It's not a standard. It's just an approach on how you publish and share data on the internet. It is not about, and that's like one of the misunderstandings we faced earlier when we talked about it. It's not about how you manage your data within your tool or within the source. It's about how you share data. It's about how you connect data, assuming the internet or the web, for example. So basically, you can get data from your different sources to connect, which means you get more meaning out of it. I mean, a requirement in a requirement tool has only a certain meaning, but if you know how it's connecting to testing, then you know more about it, of course. So that is one advantage of it. But also, when you can connect them, then you can do more interesting queries because you're getting more information. It's making more sense out of it. And that's what it allows you to do. So you're turning data, which is sort of isolated into these different silos within the tools, into information. You're getting more meaning out of it because you have these links between them. So it makes it, you can answer things like, does every requirement have a test to validate it? And that's what it lets you do. And it's letting you do that. Of course, you can connect things as you did before, but now you're doing it in a more standard way. You're adding you're adding meaning to this concept of validate. It's not just a link, it's got a meaning behind it. And that's what the linked data approach and its standards allow you to do. And that's what we will talk about today. Okay, and once you have the information connected, then you can do more complicated queries where everything is connected. Everything is still in its source. So it's a very federated kind of distribution of the data, but you can still connect it, and then you can do more complicated queries to have a better understanding of your product and how things connect to each other. Okay. Again, you can do this using, if you do point-to-point integration, you can also do this if you put everything in the one source. What linked data, the philosophy of linked data is you keep your data in the different silos or the different sources, but you can still get that same capability. So you don't have to do copy-paste, you don't have any synchronization problems, because you're still just linking the data. And that's linked data, what it is. As simple as that. Okay, all this sort of, the whole linked data principle started in 2006, I think, by Tim Berners-Lee, which defined these 4 principles and how you should sort of connect data on the internet. Basically, put an ID on everything. If you have a resource on the internet, make an URI, put an ID to it, and use a URI to identify it. So basically, everything should have an ID so you know what it is, so you know if it's being duplicated or not. And then preferably, or use, the second principle is to use a HTTP URI so people can look it up. A good example would be, for example, for a book, you can use the ISBN number as an ID. That's fine. But what do you do with that number? Where is the standard that lets you look up what it is? But if you have a HTTP URI, you can look it up on the internet, and then hopefully you will get more information out of that one. So that's sort of the second principle of the linked data approach. And then when someone looks it up, maybe you should give them some useful information. It's quite basic principles here, really, but not so always implemented. Maybe they can look it up and they can find good information about it using sort of standards such as RDF and Sparkle. So it's information that other machines can understand. So not only that you can read it, but also as a machine can understand that this is a book, that's its author, this is its content, these are the chapters in it. Put it in a format following these standards, which we will talk about, that makes sense for other machines to interoperate with. And then when you talk about the book, instead of just mentioning who the author is, maybe put a link to the author page so that you can navigate between information, so that you can link the data. So instead of just putting the author as a name of the author, maybe it should be the URI of the author resource. So people can go to Wikipedia for the author name and find even more information about them. And that's when you start navigating the internet. That's pretty much what we have. These are the principles, and then we have the standards to support these principles. But just as an example, before we go there, this is sort of an example project of what's happening. If we ignore development environments or building trucks or whatever we build here, this is sort of what happens on the internet today. There's a project called the Linked Open Data approach. It tries to suck in information from sort of government open sort of information from things like encyclopedias, music databases, research papers, and tries to sort of connect them all together, all these different sources of information. And then, you can get even more information out of it. So here, the example is information about drugs, information about public domain books, and all this information is available, but the power here is that you can maybe connect these information together because you're following the standard that lets you understand that this author being mentioned in this book is the same author being mentioned in Wikipedia, and then you can connect them together. This music store, if it makes its data available using this linked data standards, then you can connect it to the same information in another music store or at Amazon, and then all of a sudden you get a lot more powerful information from this connection. And imagine you can do that for your development environment at your company. You have your requirements people, your test people. That's good information. Imagine if you can connect that information together automatically, sort of if you just put that information behind it. So it's not only that a human can look at tests and requirements and understand that this requirements belong to this test. Imagine if the machines understand that. Then you have a lot of information to work with. Okay, so the key thing here is not only that you're linking the data, you have access to the semantics. You understand that this is a book, this is a requirement. And not only you, the machines understand this is a requirement. And that's a bit, It's a hard concept for me to understand earlier, but how do you make a machine understand semantics? I think you can help me out on that. But that's sort of what the standards try to do. Put meaning behind the data, make it information. And then also you're not isolating these silos, you're sort of connecting them together. And then from that you can discover things. You know, you can find information that you didn't have before, basically. Okay? I think this is a powerful concept if we manage to apply that in our development environment, not just on the internet for music and books. So how do we get there? What are the technologies we need to get there, to get this sort of approach working? It's basically web technologies. There are the RDF standards, which I will talk about in detail a bit more. And then it's basically the basics of web, URIs and HTTPs. Those unique URIs when you search, and then just the whole HTTP protocol and how you communicate on the internet. So I hope you're sort of familiar with these two at least, and I will go in more details on the RDF standard. So what is RDF? Oh, Resource Description Framework. It's sort of a standard that lets you describe resources, anything on the internet. If you want to describe something, you can use this standard to describe it. And the purpose of it is not for humans to understand what the data is, it's for machines to understand it. So if you go to your favorite newspaper on the internet, when you open the first page, you understand this is the front page, these are the articles, these are the headings, it's written by this person. You understand that because of the fonts being used. That's HTML, that's for humans. Imagine behind the scenes, there is, sort of, let's say XML or some format where if a machine comes into that front page, they can understand that these are articles. This is actually a newspaper website. These are articles. This is the header and this is the content. This is the author. Something tells that machine that this is an author. And that author, of course, has links to all its articles, his or her articles they've ever written. In the creation date, that's a date. When the article was created. All that information is available behind, which makes the machine allow it to connect it to other sources of information on the internet and understand the meaning of them. This is the author. This is the author's Facebook page, and this is their Twitter account, and these are all the blogs they have. They've linked to these other content from this other author and make sense of it. And that's what the standard does through XML. It's not magic, but it's sort of what the standard gives you a description of these resources on the internet. Resources could be humans, like the author, described on the web, but it could also be the article itself, which is only on the internet, let's say. So a resource is this main concept of things you want to give descriptions for. Okay, other examples. If you have an event on the internet, the time schedules. It's not only that you can understand if you go to SG and you can look at the time schedule of when the trains goes. Other machines or other servers can also go there and understand the schedule following the standard. Okay, that was another example. Yeah, and then the key concepts which I want to go through to get a deeper understanding of the standard is what is this sort of the data model? What is the basic of this RDF standard? How do they think in terms of data? I will go through in a moment this vocabulary, how you describe things, and how do you serialize things? How do you actually sort of communicate this information between servers? And then vocabularies or the semantics behind it. I will go through these one by one. I'm happy if you ask questions because then I can have a break. So, yeah. And is it sort of clear what the intention behind it before we get deeper? Yeah. Okay. So the very basis of the RDF standard is its data model. How do you express information in RDF? The basic structure is this idea of a statement. If you want to describe something, you put it in terms of 3 items. You have a subject, a predicate or a property, and then the object. Whatever statement you want to make, for example, Amanda owns a car, then you have 2 resources, Amanda and the car, and you're trying to establish a relationship between them, which is owns. And this is 3 statements. And all data in RDF is simply a set of statements like that. Amanda owns car, Amanda has name, or Amanda would be the literal, for example. And then car itself is a resource, which has its own properties, how to describe it. But that's not part of the most basic statement is just a triple of 3 things: subject, predicate or property, and then the object. Okay? Requirement has priority high. That's pretty much it. Okay, and this is sort of, if you take a requirement you have this is the actual requirement resource is validated by test case. And everything in RDF has to have a URI. Every resource. So requirement is actually, It's called a resource and it's got a URI. So you can identify it, you can find it on the internet, and you can find all its related properties. Even the property itself has a URI. What happens when you go to the property, to the URI of that property? Yeah, that gets messy. I mean, you get a description of it. What does it mean to be validated by? There's a description in RDF itself on what is the meaning of the validated by property, which is itself an RDF resource, which has its own properties, etc., etc. So the information about the data is also in the same domain technology space as the data itself. So you can navigate to. So you can navigate to the meaning as well as to the actual data itself. And then the object is also a resource. In this particular role, it's a resource, which is in this case a test case, which is also a URI. If you go to the URI, you will find more information about the test case. You will find its properties, which are themselves URIs, and then the actual values of these properties. Yeah? So in this role, test case is an object, but of course, you can have statements on this object, which is a set of other statements where test case becomes the subject of, in the role of a subject, and then you have properties, and then you have the object. Pretty basic, right? I think, yeah. But I mean, it's a very simple concept to understand, but it's sort of very scalable also. Okay, in the end, some of these properties could be literals, like a string or a number, of course. That's where sort of it ends. So the subject is always a resource with a URI. The property is always a resource with not a resource. It's got a URI, so you know about its information. And then the object could be either a resource with its own properties, etc., or a literal, a string. Okay, so this is actually how it looks like on the line. You know, you have URIs everywhere. And then, you know, if you have all these statements, what you have is you can create a whole graph of information. And that's when you start navigating. There's no hierarchy in this. It's purely a graph of relationship between resources. A work item implements a requirement which has these properties. It's validated by a test case which has these properties, etc. Okay? This is an object of this relationship, of this statement, but it's also a subject for these other statements. And you have a graph. You start here, and then you can navigate wherever you want. You can do queries with this technology, of course, to find everything you want to do.
Jad, you said that there's no hierarchy here, but you could have like some properties used for say, capturing hierarchical relationships between those objects.
Yeah, that is the meaning. So the hierarchical relationship is the meaning you're putting behind a certain property. Yeah, but in the actual, that's sort of in the vocabulary. Yeah. But in the basic basic data model, there is no such thing as a hierarchy, as in you have one node and then it sort of goes under. Everything is a resource, and then they have relationship between them. You're linking data, linked resources. Yeah.
How do you decide if Bob, for example, owner Bob, if Bob is a literal or a resource?
Well, that's, I guess, how far you wanna apply your principles of. So actually, in this is a good example, because in this particular example, you didn't go all the way, and if you want to follow Lee's principles, saying everything should try to make everything a resource, and then when you go there, you will find other information. You should actually offer more information about Bob. It shouldn't just end up with a name. So if I'm to correct this, or if you're ambitious enough, this would be a resource, and then Bob has name Bob. Has Facebook page, you can put that kind of information, definitely, yeah. That was a bad example. It's a good example to show a bad example, yeah. Okay, yeah, and then back to your example, I mean, is there a hierarchical kind of example here? I mean, a requirement could have like other sub-requirements, and then the has sub-requirement could be a property, and if you go there will be, let's say, a property saying is member of, or so to show that this is a breakdown or something like that. Yeah. Okay, so this is basically, imagine if you can do this for your whole, imagine if you can have this kind of network of information for all your data in the system without having to have a single platform. I keep pushing for that because that's like sort of the extreme. This is builds on the architecture that you can have different tools, different information silos. You just make sure you connect them following this technology. You can still get the benefits, but you have this flexibility and scalability to be able to add tools, do changes to one tool in your platform without affecting the others. And I think that's quite, that's like the internet, right? You have different web servers, you have Amazon, you have your bank system, everything, and they're all connected. And I mean, that's scalable and flexible. Okay, I don't know how clear this is with this data model, but I mean, it's it's quite basic. So I don't know if one way of looking at it is to compare it to other data models, just to see where the differences are really. Because you can put this information in a database, or you can have an object model to describe this. So where is the difference? Why is it so different? Why not use the relational database kind of data model, I should say? Okay, so I thought we can compare it to relational data model, which is what you can find in more traditional SQL databases, or object-oriented kind of data models. The big difference, if you compare to those, is this concept of closed world versus open world assumption. This is hard for me to explain what it is, but basically, when you model in terms of, if you're modeling a class model, or you have an object-oriented kind of mental world, how you want to describe the world, there you say things like, if you're of a certain type, then you should have these properties. If you're a person, then you should have a name, you should have 2 eyes, 2 legs, etc. It's really sort of a closed world of looking at the world. Like you define things by the set of properties you have. If you don't have 2 eyes, you're not a human anymore. It's pretty much what it says. In the RDF, which is sort of trying to reflect the reality of the world, is that, you have these properties, you must be a human. You have 2 eyes, 2 legs. I mean, how do I identify that Frederick is a human and not a coffee cup? He's got 2 eyes and stuff. So by looking at your properties, by looking at the statements of all your RDF statements that says where Frederick is a subject, Frederick has 2 eyes, Frederick talks, blah, blah, then I identify him. I make a conclusion that Frederick is a human. But that means that also I'm tolerant. If Frederick comes up with 1 eye one day, I can still tolerate that and think, okay, he's still a human. You know, it's only one property out of many. This is sort of my understanding of this difference between them. In the object-oriented worldview, which is more closed view, is like you come with 1 eye, you're not a human anymore. You know, exception handling and all that kind of stuff in your program. And I think this is pretty much a powerful thing, because when you want to integrate tools, it's not perfect, right? A requirement tool could have different kind of properties or missing certain properties compared to another one. And that's what makes this sort of platform or point-to-point integration so hard before, is because you do expect everything to look the same. That's sort of how we engineers also like to think. A requirement should have name, description, author, etc. We don't tolerate this difference. If we take this linked data approach, ignore the standards, just the way of thinking where you say, we can tolerate a requirement even if it doesn't have a name or if it doesn't have an author. I think you create a lot of flexibility in your data model, or where you sort of analyze your data. And that's sort of the big difference here. I don't know if that's clear. It sort of takes a while to sink in. It's more of a, I'll leave it at that. Maybe we'll get back to that later. And then the other difference is that in the RDF model, the actual properties themselves are first-class citizens. So if you compare to an object-oriented model, you define your classes and then you add properties to them. If you remove the class, the properties also disappear. They belong to the actual class itself. Name is just a property, an attribute of the class. In RDF, the properties themselves are defined on their own. They have their own URI and they have their own meaning. And then resources can sort of reference these or use these properties to reuse them, which makes a better reuse, but also makes sort of these properties independent, let's say. I'll show an example on that. This is just a detail. I mean, in the object-oriented model, you have methods also, of course. In RDF, the focus is only on data. So there is no such thing as methods or operations in RDF. It's purely focusing on the data. And then there's no such concept as private, public. Everything is public data, unless you put that as a property, I guess, or something. I'm not sure. Okay, is it clearer what this linked data, the graph model is, sort of the basis of the data model? I think that's like fundamental to RDF. So if you're implementing and you sort of come from this object-oriented, or you have a database, you have to do a mental transition also on how to think about your data to do with RDF. And I guess it comes out of the necessities that when you're on the internet, on the web, you cannot specify how data should look like. You should be flexible on how things are described. And that suits better how things are, more federated and autonomous in a way, the data source. Okay, so this is another example. This is the same information. I'll try to compare. How does it look like if you have a database and you have different tables? This is a requirements list of tables. This is the releases sort of kind of information, and that's your test case. And in a more relational kind of model, you have the information in a table. You have rows for every piece of information. And then the release, then you put a link. It's also a link, right? No big deal there. You can do that in a database, linking data. And this is sort of the same information put in the linked data sort of data model. Can you see this? I mean, I don't know what this is sort of following this closed world assumption, and this is more the open world assumption. Can you see the difference? I mean, what is the implication of doing this kind of implementation to this kind of implementation?
It's like each column in the relational database is like one object by itself.
Each row is an object. Yeah.
I mean, when you go to this other way, every column is like as important as the class. One class, one table is.
So when it comes to columns, this is like they say release. This is that column there, and this becomes this property release here, which is described on its own also. But what I've been thinking, my point here is that when you design the schema, this link is expected to be there. You know, sort of. I mean, of course you can. I mean, let's assume that you say a release should have. Sorry, a requirement should be associated to a release, and then that is expected there, and that's sort of by definition it should be there. In this kind of worldview, you don't have a definition saying that should be there. But by looking at the world, you sort of can see, oh, this is the relationship. Then you make more sense of it. You're tolerant to the fact that a requirement doesn't have an association or a link to a release. Of course, you can say that this release value could be null, also your definition, but it's still in your definition. Here, you don't specify things. Here, you just try to make sense out of the data you have instead of specifying how data should be. That's sort of what I was trying to get at. Okay, so this is, I was talking about the graph bundle. That's one of the basic technology, like the basic ideas behind RDF. When it comes to sort of the vocabulary means, I mean, how do you define the meaning of things and stuff? It's URI based, as I said before. So all the properties have a URI that describe what the properties are. So if you want to identify anything, you use a URI. When that makes things linked, because everything that has the same URI becomes the same subject, which links to other kind of properties. And that's the key thing that I think I've already highlighted is the fact that even the property has a URI. Everything has a URI, which means that you can get information behind it also. Okay, now this is sort of the data model. How do you communicate this data model between things? Then you need to serialize it. So RDF is purely what I've said so far. Now, if you want to communicate an RDF, a resource is what we talk about. A resource is basically a set of statements where the subject is the same. How do you communicate that between systems? Then, in the standard, there are serialization syntax. You can use RDF XML, which is sort of a derivative of XML. You can use Turtle, I think it's pronounced, which is a specific serialization format. That's like how you convert this data into text so you can send it on the line. Or you can use just JSON. So the standard itself covers all three. You can choose whichever serialization format you want. It's not, so the XML is only, there's some confusion sometimes I realize that XML is just the serialization form. It's not the RDF itself. It's the data model you have to have, which is the RDF. This is the data behind it. And then it could look like this if you're using XML to serialize it. But that's not the data itself. Okay, and I don't know if it's even interesting to look at that, but it could look differently on the line. And this is not meant for humans to read, so sometimes I don't understand what the big deal is about XML or not. I mean, send it on the line. The main important thing is that the information is there. But maybe I'm oversimplifying that. Is that clear? Fine? Yeah. Okay, so far I've talked about RDF is just describing resources. It doesn't really say it's just about how you describe the data you have. But sometimes you want to define the meaning of the data, the vocabulary of the data, what are you allowed to do and not to do. And in the RDF family of standards, there are two approaches called RDFS and OWL. OWL, it's called. And this is sort of how you define the kind of resources you have. What kind of resources, a person, instead of saying Frederick. RDF talks about Frederick, but RDFS will allow you to talk about a person and parents and that kind of relationships. Okay, this is a RDF schema, which is sort of a basic framework where you can talk about classes of resources, subclasses, and sort of properties of it. That's quite basic. And then there's more advanced kind of, you get into ontologies, and that's OWL, where you have a very complex, more formalized language. And it gets quite mathematical. And maybe you can help me there, but if I understood it correctly, I'm assuming that's what you work on. But it really gives you, if you describe your language, your vocabulary using OWL, you can do like formal mathematical analysis on it and deduce and infer new information from the data you have. So it's quite powerful mathematical tools you have. OSLC on the side where they sort of borrow some of this schema, but they sort of don't take this approach. They have another approach on how you define the vocabulary. It's just to understand you, is this what you work on roughly? Is that correct? Okay, that's what. Yeah. So basically what OSLC uses, it uses this query language, and that's sort of how do you ask the questions to infer based on it, and then uses RDF, a little bit of RDFS, but it doesn't go that far as using the OWL for reasons that they will motivate. Okay, so I think I'll talk a little bit more about this RDFS. It's basically an extension of RDF, where, I mean, you know, here we talk about, this is a presentation I had at Scania, so of course I had to have trucks. So RDF talks about the truck instances, and RDFS lets you talk about the meta class of trucks. Pretty much classes or object in object-oriented view. But it's only the mechanism to do that. It doesn't really define a truck. What you do then, and okay, another thing before I go into that is, so this is a description of a resource, and part of the description is a property. I don't know if you can read this, but you know, it says RDF type, and then it has a pointer to the actual class. So part of the description of the instance, you have one property called RDF type, and that points to the description of the class itself. So these objects and this class object itself belong to the same domain of RDF. You describe them in the same way using RDF. In the object-oriented worldview, you have, if you think UML, you have objects, but then the class description is at the meta level. In RDF, you don't have this. They're all on the same sort of RDF level, described in the same way. Okay, this is an example of a vocabulary based on RDFS, just to give you an illustration. The Dublin Core Metadata Initiative, it defines a set of properties on how you describe documents. So this is an effort out there that tries to come up with this vocabulary so that when we go to Wikipedia or a web store, if they apply this standard, they can understand what it means to be a publisher or a creator of a book or of an entity or something. And it's pretty much saying this is the property and its meaning, and then it's got a URI where you can go there and get more information about it. Pretty trivial, but at least it's a standard. So if everyone follows that standard of what is, if everyone puts this URI for a creator for whatever it is, then you understand the meaning of it. It's standardized. Just an example. And the idea is maybe we can do this for, you know, requirements. Maybe we can do this for change management, etc. All your artifacts in the development environment could, if the community can agree on these standards, then we're there also. Not only for, you know, Facebook and Wikipedia. Okay, actually, yeah. So I don't know if I've presented RDF, and I started with this picture saying what you could do using linked data approach. And given what I've shown you about the sort of the standards, I don't know if you got an idea on how this lets you, how did this allow these projects to come up with this kind of information and have access to this linking of information. Can you imagine this at your company if you're developing something and you connect all your thousands of different sources you have of data? A lot of it is duplicated, some of it is missing and stuff, but you can still do that. Yeah. I haven't even talked about OSLC, I just talked about linked data, which is the standard. So, yeah.
I think a question that might also pop up when you want to apply these kind of principles for systems engineering development environment. You will need also to put some of this data under configuration management to some extent, because if you have a lot of couple of distributed development teams working together, so you have to check in, check out this data on a regular basis, and it has to be consistent. And so the linked data principles, as you just presented, are like very basic. They do not cover at all configuration management, but it's like a kind of layer that has to be provided on top of it. And maybe we will be talking briefly about that in the second slot of this morning session, because there's like an ongoing specification in OSLC for managing configuration management, for providing configuration management related features on top of linked data.
Yeah, so I mean, I haven't talked anything about OSLC, and I tried to squeeze in something about development. This is purely linked data and what you can do out on what people are already doing on the internet with that kind of tool. But for development environments, or sort of that's that's when we need OSLC. That's what OSLC will come up with. Yeah. But this is sort of the basic assumptions and philosophy behind it of what we want to get to. And I think this is a better way of coming to integrating our tools. It's a better approach than whatever we had tried to do before.
And I think what is really interesting here is the fact that it relies on web technologies in principle. Because when you think about like a middleware that has been like widely adopted, I mean, it's really internet. So in this case, we really want to rely on internet technologies to expose this data and link this data together. So I think this is like quite like interesting idea. Yeah. So when I want to crack half of a joke, sometimes I say that linked data or OSLC can be a kind of like a Facebook or LinkedIn platform for system or software engineering development. So it's really relying on web technology. So this is really interesting.
It's actually hard to explain sometimes what OSLC is, because it's like, where is the binary, or where is the platform, where is the bus where you put it? And it's just the Ethernet cable. That's all you need. The rest is in the different sources. So it's, that's what makes it too trivial maybe for some people. Or, yeah. Okay, is it perfect timing or am I wrong? It's like 1 o'clock, wow. Because I think that was my next step, is to go through the standard itself. But I hope you have a good basis. Thank you.